How's it going, Lone Riders? Let's have a look at how we develop the products. So if you're new here, we develop products and we put them on YouTube and show you how we do it and all our thinking. We also get feedback from you. So if there's anything you think of during this video, let me know in the comments down below. And while you're down there, hit that like button, subscribe, and little bell icon just to help me out a little bit here. So this week, we're going to talk about how we developed this rackless system. We just go through the whole process from the start to the finish, including manufacturing, all this kind of stuff, and just talk about how we did it, because having this insight of how we developed it is really interesting for a lot of people, and it also shows you the depths that we go to try and make this product as good as possible. So they're on pre-sale since last week. This is October 2022 if you're watching this in the future. So they are on pre-sale, and they're only going to be on pre-sale for a short time. The reason why we do pre-sales, for many reasons, just to make sure that our tribe gets a really good deal. That's one of the biggest reasons we do it, and also it gives us an idea of how much we produce for the first batch. I prefer just to do smaller batches and then ship them out in smaller batches, because then I can control the quality much better. So we have a quality guy, he can focus on every part, and we can make sure that they come out of the factory perfect. That's why we do small batches, and that's why we do a pre-sale. So let's just jump into the computer and we'll go through the process. First question is why and what products do we make, and why do we make the products? We came to this product because a lot of people like the MotoBags, and we also like this kind of beautiful integration between a rackless system. So we thought we could also introduce some kind of system, but also do something completely different and not use hard casing, and use our semi-rigid system, which a lot of people use and a lot of people like. So we want to integrate those two fields together, the rackless and the semi-rigid concept. So if you look on the left here, we've got a BMW R1250 GS Adventure, and this normally comes with racks, and then we supply them with a quick release system that we currently sell on the web shop. But for the guys that have a GS and standard GS, then they need to add racks to it, add more weight, and also add our MotoBags to it. So we are actually, this is more focused for the GS riders. This is plug and play over the adventure guys, but the adventure guys, it still works on the adventure bikes. I'll show you that in a minute. We do a lot of product research. This is just quickly overview. We look at what's on the market, because that gives us a lot of insight of what people actually want and how to solve problems, and if it's even worth validating the product and moving forward with it. Market research is integral. We also ask you guys a lot. We have email lists, and we email you guys, and you guys give us a lot of feedback. So this is an integral part of the design process. So that's what the first step we did here. So we've got the BMW, they do it, essentially 2 hooks and a foot down there, 3 points. Honda do it as well. There's essentially the same system, 2 hooks and on the passenger foot peg here. Also a connection point. These guys actually come up from underneath. And also the Suzuki guys do it as well. Always the same concept, 2 hooks and a foot system that connects the 3rd point. So we're looking at here that a lot of people use this system because it works. So we're probably going to go along this as well. There's no point in like redesigning the wheel, right? So the other platform we have to consider is what product we integrate this with. And obviously it's going to be MotoBags. But we can also use it for other products and stuff like this. We haven't thought about this, but we could also move it into different systems. But essentially, this is the main product that will clip onto. So we have to consider this when designing everything. We have to use how do people use it? What do people use it for? When do they use it? How do they handle it? What weights and tolerances that everyone uses and needs through this product? So we have to consider this as well. So we started off with our backplate, our existing backplate. This is for the quick release system that we already have, just to get a location and start figuring out what goes where and how. So we take a 3D scan. This is a 3D scan data of my bike, and we try and find out all the points and try and get a kind of rough idea and visualize this idea into a CAD model. And this CAD model gives us kind of like a form, dimensions, and visual space that we can share and develop in. So pretty quickly off the bat, down the bottom here, we came up with a system. We actually were quite lucky on this, because we actually got to this quite quickly. Normally it takes a lot of iterations to figure it out, but I guess that comes with experience and understanding the market. Our team is pretty knowledgeable in the market, so we kind of warp speed it here. Here we're just trying to give the best possible user experience. One of the first things we had to consider was the attachment points, and a really good system is the hook system. And what that does is locates on all axes, and it carries a lot of weight. So we really had to look at the bottom part and look what we did there. With the BMW bikes, there is 2 passenger foot pegs, and the difference is that if you order the luggage package and the racks, they generally swap out the passenger foot peg and put another foot peg on there to make it compatible. So if you look on the top left hand side here, this is what you'll get when you order with the 1250 and 1200 GS, when you order the luggage package from BMW. At the bottom is the GS passenger foot peg system, which is Vario compatible. And this comes as standard, essentially, the bottom one here. So that's the difference. So if your bike has a Vario capable system already, then you don't need to do this system that we designed as plug and play. But if you have the adventure version and you've ordered the racks, or the bike has racks, and the passenger foot pegs look like this, and then I'll explain in a moment what the options are. So in the middle here, the Vario system that BMW produces also works on the 850 and the 750. So they also use 2 different passenger foot pegs if you order the luggage rack system. So at the bottom here, this is compatible, and the top here, this is just when you order this luggage system or this rack system. And it doesn't work because they put in a plate here to use this front bolt here to attach to, just to give it more stability. So here you can see there are 4 different types of passenger foot pegs for BMW's 850s, 750s, and 1250s and 1200s. So if your bike has this first one here, then it's compatible. If it has the second one, it's not compatible, but you can either go to BMW and buy this system. Depends where you are, depends on cost. I'm not sure exactly how much it costs in your region, but if you check out, if you have an adventure bike, you have this foot peg and you check out with the adventure package, we include a adapter kit for that. It just needs a few bolts to change out and you're good to go. If you have an 850 or a 750, most of the time they come standard with the compatible system here, most of the time. If you order the luggage package with your bike directly from BMW, what they're going to do is they're going to swap this passenger foot peg out and put this foot peg on, and that'll give them another fixing point, so to make it stable, the luggage system. So you will have to order that from directly from BMW. So that's the explanation for the third point, the connection point, and the passenger foot peg connection for the bikes. It's also on the product page, trying to make it really clear, but that's what we had to work around. So we essentially had to develop a system here for the guys that don't want to spend extra money on upgrading their passenger foot peg to make the system work. So we started off with a few concepts, but the first concept was how do we integrate it as seamlessly as possible. And we're thinking sheet metal, so we're using cardboard here to render out some size and get some ideas. And we wanted it to be easier just to throw in there. We didn't really want to look at it. And we found this works well, but what we found after trying a few times anyway is that our muscle memory actually came into action, and it just went on there anyway. So there's no need to improve that kind of experience. The first round of design, this is the first round of design. Well, this is what we came up with. It's in CAD now, it's pretty primitive. And this was the first round of CAD that we had. And then from here, we would build some models off, some actual 3D models in real space, so we can actually test it on the bike. So our first prototype I made out of plastic. This is just plastic, and I bent it with heat. We laser cut the shapes out and bent it. It was very rudimentary, but we wanted to prove the concept. We wanted to make sure it worked, right? So this was the first one. You can see here the hooks are a little bit different. This is 3D printed. All of this parts are 3D printed, and I had to space out the locking system and things like this. I've been drawing on this because I've been sending this to people to upgrade and stuff, like change the design and things like this. But even the HCP backplate here, this is just getting the material and the thicknesses and stuff there. It's not for looks or anything. It's just like literally the first concept we need to test it on the bike. And does it fit? Is it even going to fail? Is the whole project going to fail? This was the concept here that made us decide if we go further or not. So once that was approved, we made a lot of changes to the design. Just from this, so that was V1 essentially, and then we spent several months again to try and develop it in CAD, and this is what we came up with. It was the second V2. So the V2 is made out of aluminium, so we can really start testing it. Testing means crashing it, and like really trying it out, and testing out the new CAD. So I made a bunch of them, I think 5 sets or something, and I sent this out to several riders around the world to test and give feedback from. And this is, I went into our workshops, and actually designed this. We got the parts made, and so essentially this is also 3D printed plastic parts, but it's solid plastic parts, real back plates, HDPE, and aluminium as well. So these are working prototypes. That's the next stage. We tested it a lot, and we figured out quite a few issues that we had. And so we had to fix it. For example, we wanted to test how strong it was. It was breaking out indicator lights. It was too big. You can see here backed up onto this back indicator light. They change out the indicator lights for the big ones and the small ones, and things like this. I also made a video of testing how strong it is. So I want to see here how it reacts to basic movement. Clearly we're not driving fast here, and it's also not designed to go crazy and slide along the road at 50 k's an hour. It's only got 3 attachment points. It is not as strong as the quick release system. So if you're into off-roading, then definitely go and check out the quick release system that we have. It's much stronger because you're utilising a rack system, and it has much more points of attachment, and that weight can distribute all around. But yeah, it passed with basic falls and basic slides and stuff like that, and it still works. So it was a very, very successful test, and it passed. This is another video from Tom Barra. He just drove it into a tree. So Tom's quite a skilled rider, and he just takes everything to the limit. So we send it off to him, and he drives into trees. I mean, if you're going to drive into a tree, you're going to damage something. It's going to break. So also feedback. Of course, we made videos and we sent it out, and of course, like a couple of people said, yeah, way too bulky, way too bulky. So yeah, we reduced it. We took that feedback to heart, and we reduced it a lot. The sizes and the weight and the volume, and we just retracted that right down. Going back to how hitting the tree with the bike and testing it. So we learned that what happened is the metal bends a lot in this area here. So, and we found out what parts break and where they break. So what we do, if you actually look at our design, and the actual one now, we've actually cut in here into the metal. So when it does have that impact, it just bends on that and doesn't mess up the locking system. So it's an improvement that we integrated among other things. That's the importance of testing. We also reinvent each part several times. This is one part. This is the foot system that connects to the passenger foot peg, and this has got V1, V2, and V3. So the very first design that we did broke quite easily, and it was a chunky part. It was a big piece of plastic, and it was extremely expensive. So we went to this next phase, and we integrated metal and steel inside that to overmold. Overmolding is when you have a steel carcass essentially, and you melt plastic around it. Again, this worked really well, but this didn't serve us properly good enough. We couldn't adapt it that much, and also the tooling was extremely expensive. So we went on to the third one, and essentially it's just a piece of aluminium, a custom-made protrusion of aluminium, and 2 parts. There's a rubber part at the back and a plastic hard part at the front, and that reduced our costs massively, because we can't sell it to you if it's too expensive. It's not the point. We're trying to make cheap products here. We're trying to make it accessible. And things are expensive. You wouldn't believe how much this stuff costs, actually, the raw materials and stuff to buy. It's not cheap. And so that's what we're trying to do. We're trying to refine it as much as possible. But I'll come to DFM in a moment. A lot of people also ask for to have a cubby hole, like a toolbox in the back there. So we did try to build it in. You can see here there's a key and a door system, and there's a little bit of space inside there. But what we found is it was just too sharp in there with all the screws and stuff like this. And actually, because we reduced it so much, the size of it, there's not much space in there anyway. And also, who wants to walk up to their hotel room or walk across a field with 10 kilos of extra tools? Trust me, you don't want to do that. It's better if there's tools and stuff stay on the bike. we did think about adding one of the Lone Rider bags here, but also we've got to think about if that sags, if it's not installed properly by the user, will it come off and go into the Betrieb system? Will it go into the operating system of the bike? We don't know, so we're going to not do that right now and make sure we think about that properly, because it can be, it can make massive problems if that came off and if it's not installed properly by the user. And that's our problem. Also the backplate, we updated the backplate and used HDPE. It's really strong. They use it on skid plates, they use it on kayaks, they use it on everything. So we introduced this as well. If you see on our aluminium one, it's 4mm and it bends, and this is after a major accident here. This is the feedback we get from customers. They send us this in, and we learn and develop it further. So this is actually quite rare. So, I'm surprised it doesn't happen more, to be honest. But it's quite a good system, what we've got already with the aluminium backplate. But we decided to go with a little bit lighter version because we can with this design, and we also need the thickness of the HDPE. So we're going to design that. We've designed that into the product as well. And as you see here, I'm also testing prototypes to integrate that into our current quick release system as well. But there's things we just don't know about, like how do screws react if they're moving over and over for thousands of kilometers over dirt. Do they start eating in to the material, to the soft material? We've got to test all this stuff. So it's not just like we can't just do it and integrate it straight away. So about the size, this was V1 down the bottom, and this was the V2. So you can see it's a massive reduction in size, huge reduction in size. So our CAD is accurate, but not that accurate. Once it's visualized in real space and real reality, we can make changes. So from this DFM results, from the reducing everything, we saved like 14% in weight, which is huge. Parts, we reduced parts by 44%, and so which is over a kilo for a set, and 84 parts. 84 parts in total, which is massive. It reduces so much more costs and technicalities and parts that break and stuff like this. So that's why we go through these stages of development. We learn along the way. So DFX or DFM, different people say different things, but essentially I just want to quickly touch on this, because once we've designed it, okay, we've got the concept solid. Essentially we have to design it for the manufacturing techniques that we choose. And this is very important. This is make or break moment for the project, because if we don't do it properly, it's too expensive to produce, or it just doesn't assemble, or parts break. It's just not a good product. So this is make or break. So essentially what DFM is, we have the base form, we have the basic function, and then we introduce all the functions to make it work in the tool, so we can actually use it. We introduce overmolding and things like this, and then we also, if you notice here, like the two blue areas, it's like a 1 degree. So we have to, it's all very, very fine work, and the reason for that is so we can actually take it out of the tool and stuff like this. So it sounds like a novel thing to do, but this is extremely time intensive. This takes massive amounts of time to implement, because once you change one part, it could affect another part, which could affect another part, which is like a chain reaction. So this is why it takes so long to do this. And one of the last parts is really start manufacturing the tool. So once we confirm everything, we get a rough estimate quote from the suppliers for the different materials. What we do then is we pay for tooling, and this is like the moment where you are not, your skin's in the game. You are investing a lot more money into it, and time and effort, and then you've got to pay for the tooling, and tooling is essentially to be able to get a consistent piece every time and at volume. So yeah, that's the next step. We list every part out, we tell it exactly, we give it names, we give it SKU numbers, we give it materials, surface treatment, everything like this, and we go through it and we define every little bit of the product, just so it's all clear, because if you don't define it, it's up in the air. You need to think about everything. So essentially, this is what we do. It's a BOM, which is bill of materials. We do this as just one sheet that we use, one manufacturing technique. There's many other things that we do, but we also make the drawings. Spend a lot of time making the drawings because we have to have tolerances. It can't be too big, can't be too small. And if you look here, it's there's tolerances. We've got up to 0.1 millimeter, and that's the tolerance, plus minus. Can be we can bigger or smaller than that, but we've got to specify this because heat shrinkages from plastics, we've got tolerances that we all need to keep, otherwise the product just won't work or it won't fit on the bike. If you don't specify it, you have nothing to fall back on when something doesn't work. Another thing is we get, this is an image straight out of the injection molding, so to reduce cost we've put all these parts into one tool, and we also purchased the back system, rack system BMW as a checking jig. So what happens is the checking jig is fixed, we make sure all the measurements are correct, we weld it into place so it can't move, it can't be changed, and then what we do here is we use it to test every piece left and right. So every piece that comes off the production line gets tested on this jig, and often we check those tolerances quite often every couple of hundred pieces to make sure the jig hasn't moved, because if it moves a couple of millimeters or 10 millimeters, it's we're going to have problems with the product. So that's why we do every couple of hundred tests, we kind of retest the test, which is the jig. And what we do is we also produce a set of production parts. So we put these production parts together. That we learn a lot from this, because when they come out of the tool, there's a lot of things that move, there's tolerances, stuff like that, as I said before. But essentially we build it and we learn how to assemble it efficiently. This is also important. So how does it work? Do we need to change anything? And often, even though we're pretty accurate and we've been through many iterations of this product, we still need to change some stuff. So we're changing stuff already, we're still changing stuff, and we will continue to change stuff after we've actually produced the first batches, because we're always going to have to improve. So I was going to make a video about how to put it on and off, because in the last video in the comments you were going, how do we put it on and off? So I'm just going to let Alex show you with his nice beautiful videos. So yeah, here, so I've got the music. So he's putting the left and the right on. This is a GSA, and it's got our adapter for pegs on it, and that's how quick it is. Essentially there, you don't need to lock it. Once you close the handles, then it's locked in place and it won't fall off. But if you want to lock it to there, like literally lock it with a key, then you can just also do that pretty quickly as well. So yeah, that's it. It's just gone to pre-sale last week. Really excited about this. If you like that video, I'll produce more. I'm going to continue producing more. So hit that subscribe button and that little bell icon while you're down there. Like button as well. It helps out a lot, the algorithm. And yeah, if you have questions or something like that, leave us a comment. After the first week, I can't check all the comments. So if you do have a question that's really burning, do email us. There's a link in the description down below to that form, and we'll get back to you as soon as possible. So that's it. That's how we designed and developed this product. Hope you enjoyed that. Catch you soon. Hooks on top are pretty good. Okay, so